This video is about using proportional theorems to find missing side length or value. So the first theorem that we're going to talk about is side splitter theorem. So side splitter theorem is if a line is parallel to one side line, it intersects the other two sides and divides them proportionally. So this type of problem happens when there's really one triangle inside another triangle. And what happens then is because BD is parallel to AE, these two sides are now proportional to each other. So instead of doing the small triangle over the side of the larger triangle, we can just do the two sections together. So we can have CB over BA and CD over DE. This only works, though, if they are the sides of the triangle. If they're the parallel lines, you cannot use this theorem. So in number one, when we want to solve for x, we can use side splitter here because BD is parallel to AE, and the numbers are on the sides of the triangle, not the parallel side. So because BD is dividing the two sides, we have x over 12 equals 15 over 18. So when we cross multiply, 18x equals 180, x is 10. Now, in number two is an example of when we can and when we can't use the side splitter. So for x, we can use side splitter because x is on the sides of the triangle, which is being divided by the points B and D. So in order to solve for x, we can use side splitter. So we have 3x plus 2 over 10 is equal to 6 over 12. When we cross multiply, 12 times 3x plus 2 equals 6 times 10. 36x plus 24 is equal to 60. We can subtract 24 from both sides. 36x is equal to 36. When we divide, x is 1. Now, when we solve for y, because y is on the base of the triangles, we cannot use side splitter, so instead, we need to use the similar triangles. So, the two parallel sides are corresponding, they go over each other, y plus 2 over 4y equals. This is where we have to be careful. So I'm going to pick this side over here because it has numbers. So the side from the smaller triangle is going to be 6, which goes along with the triangle for y plus 2. We're not going to put 12 in the bottom, though, because we need the whole side of the bigger triangle. So we're going to add 6 plus 12 to get us 18. And then we can cross multiply. So 18 times y plus 2 equals 6 times 4y. 18y plus 36 equals 24y. We can subtract 18y from both sides. 36 equals 6y. When we divide, we get y is 6. Now we can move into problems that look like ladders, which will help us use our side splitter theorems. So in this case now, it still is the same idea here, just the lines are not coming to a vertex that we can see. So when there are 3 or more parallel lines that intersect the two transversal, the parallel lines divide them proportionally. There are 3 types of proportions we can set up depending on the information we have. So the most useful then is that A over B is equal to D over E. We're just using the little parts of each line. Now, this might not always work though. For example, if A and B both have variables on them. So we could also use A over the whole side C equals D over the whole side F, or B over the whole side C equals E over the whole side F. But most of the time we're going to try and use this first one if possible, but it's not, like I said, always possible if there are 2 of the same variables in their place. So in number 4, we have the sections of our line, so we can just set up our side splitter. 5x plus 1 over 12 is equal to x plus 6 over 14. So as we cross multiply, 14 times 5x plus 1 equals 12 times x plus 6. So as we distribute here, we get 70x plus 14 equals 12x plus 72. As we subtract, we get 58x is equal to 58. When we divide, x is 1. In number 5, this is a ladder problem just turned on its side, so we can still use our side splitter here. If the whole length of the segment up top is 20 and part of it's 12, we can subtract to get the remaining part is 8, and then we can set up our proportion. So we have 12 over 8 equals 2x plus 5 over 10. We cross multiply, we get 8 times 2x plus 5 equals 120. 16x plus 40 equals 120. We can subtract 40 from both sides. 16x equals 80. When we divide by 16, x is 5. Now remember that this only works with parallel lines. So if we are looking here, we see that this line does not have an arrow. So it is not parallel. So we cannot use side splitter there. But we see that the rest of the lines have an arrow, so they are all parallel. So if I want to solve for x, I can look at this middle section here, and I see that the whole length is 32, one part is 20, so when I subtract, I get 12. Now I can use that to set up a proportion here to solve for x. We have 12 over 20 equals x minus 1 over 10. So as we cross multiply, 120 equals 20 times x minus 1. 120 equals 20x minus 20. Add 20 to both sides. 140 equals 20x. Divide, and x is 7. Then to solve for y, we can use these 4 sections. So when we set up our proportion for y, we have 20 over y plus 15 equals 10 over 14. So as we cross multiply, 10 times y plus 15 equals 280. We can distribute the 10 and subtract 150, so we get 10y equals 130. So y is 13. Then we can substitute in to find the lengths that we need. So anywhere I see an x, I can put 7 in. So 7 plus 7 is 14. 2 times 7 minus 10 is 4. 7 minus 1 is 6. And 13 plus 15, because y is 13, is 28. So before we finish this problem, we need to find 2 different lengths. So we need to find the length of AC. So from A to C is 2 sections that are 12 and 14, so that would have a length of 26. The other section that we need to find the length of then is GJ, which is these 3 sections that are 6, 10, and 14. So 6 plus 10 plus 14 would have a length of 30. The last proportional theorem then is the triangle angle bisector theorem. So an angle bisector of a triangle to the opposite side into 2 segments which are lengths proportional to the lengths of the other side. So if we are taking our angle bisector here, these 2 sides are being split. So the side that is on the same side of the triangle is going to go in a ratio together. So we have BD over BA equals CD over CA. So in number 17, when I set up my ratio, I would have x plus 2 over 10 is equal to 2x plus 1 over 14. So as we cross multiply, 14 times x plus 2 equals 10 times 2x plus 1. 14x plus 28 equals 20x plus 10. As we simplify here, we get 18 equals 6x. When we divide, x is 3. So in number 8 now, we know the total length opposite of the angle bisector is x, and we know one part is 10. So we can subtract that from x to get our other part is x minus 10. So as we set up our proportion, we have x minus 10 over 30 equals 10 over 25. So we get 25 times x minus 10 equals 300. We can distribute the 25. 25x minus 250 equals 300. Divide by 25, or add 250 to both sides. 25 equals 550. We divide by 25. X is 22. In number 10, we know that the parts here, the whole length is 7, but we don't know the individual. So I'm going to call one part x, which makes the other part 7 minus x. So when I set up my ratio here, x over 8 equals 7 minus x over 6. As we cross multiply, 6x equals 8 times 7 minus x. 6x equals 56 minus 8x. We can add 8x to both sides. 14x equals 56. So when we divide, x is 4. In number 10, we want to find x in the two parts of the base. So here we have two different triangles. We have the yellow triangle going one direction, and we have the blue triangle going the other direction. We have x in that middle line going to where they intersect from the base. We know the base is 75. So we can call the other two base y, and then 75 minus y. So if I redraw these triangles, I have 20x, y, and 75 minus y. This whole length is 75. And our larger triangle, we have y, 75 minus y. This whole side is 75. And this whole length is 100. So in the first triangle, if I were to set up a proportion, I would have 75 minus y over the whole length 75 equals x over 20. And when I cross multiply, I get 75x equals 20 times 75 minus y. When I distribute, 75x equals 1,500 minus 20y. Now I'm stuck because this has an x and y. So I'm going to move to the other triangle. And when I set up a proportion, I have y over 75 equals x over 100. As I cross multiply, I get 75x equals 100y. Because they're both equal to 75x, we can use substitution. And we can get 1,500 minus 20y equals 100y. We can add 20 to both sides. So we get 1,500 equals 120y. When we divide, we get that y is 12.5. So part of our base is 12.5. 75 minus 12.5 will get us 62.5. And then to solve for x, we can put 12.5 in for y. So 75y equals 100 times 12.5. 75y equals 1,250. When we divide by 75, we get y is 16.67.